Imagine if someone just flipped off the universe's ultimate architect for exactly 3,600 seconds. Right now, there is an invisible, totally unyielding force holding you down, keeping your coffee in its mug, and locking the oceans onto the surface of the Earth. We treat it like the floor beneath our feet, right? Completely boring, constant, and indestructible. But what if we found a cosmic breaker box, and the switch for gravity was just flipped off, everywhere, for exactly 1 hour? Now, it's super tempting to picture this as a really fun, floaty astronaut adventure. You're just hovering around your living room, doing effortless backflips, catching floating grapes in your mouth. But unfortunately, that is not what the science tells us. This 60-minute countdown would absolutely not be a zero-G playground. It would literally be the most violent, mind-bending, apocalyptic breakdown of physics in our planet's 4.5 billion-year history. So strap in, literally, because we're taking a minute-by-minute journey through the end of the world as we know it. But before we completely destroy the world, let's define what we're actually losing. Section 1. What actually is gravity? The invisible pull. To really grasp this disaster, we've got to look past Sir Isaac Newton. Back in 1687, Newton visualized gravity as this invisible pulling rope between objects. But then Einstein came along in 1915 and proved gravity isn't a pulling rope at all. Mass actually bends the fabric of space and time. Picture a heavy bowling ball sitting on a soft trampoline. It creates a deep slope, right? An apple doesn't fall because it's sucked down by magic. It falls along the curved slope of space created by the massive weight of the Earth underneath it. Gravity is basically the universe's giant elastic band, trapping our atmosphere, compressing our molten core, and locking us into a warm orbit. So, what happens when that elastic band simply vanishes? Section 2. The first 5 minutes. Absolute weightlessness. So, T-0, the instant gravity vanishes, there actually is no dramatic explosion. There's just weightlessness. You know that exact stomach drop sensation you get at the very peak of a roller coaster? It's exactly like that, except it never stops. Unanchored objects just hover in place. It feels deceptively thrilling for a second. But we are forgetting a massive, fatal detail about the planet we're standing on. The crucial point here is Newton's first law. Objects in motion stay in motion in a straight line unless acted upon by a force. Well, Earth's equator is spinning sideways at 1,670 kilometers per hour. Gravity was the force bending your path around the Earth's curve. Without it, your body wants to travel perfectly straight, but the Earth's surface continues to curve away. You aren't actually flying up. The ground is rapidly dropping away beneath you at tremendous speed. Your immediate survival in these first few minutes completely depends on where you are. If you happen to be indoors, let's call it scenario A. Your house acts like a giant protective box. You float up, you probably bump your head on the plaster, but hey, you're contained. You can grab onto a pipe or a heavy fixture. But if you're in scenario B, outside, there is no ceiling. Cars on the highway lose traction instantly, spinning their tires at 70 miles per hour against empty space before drifting helplessly into the sky, crashing into each other like zero-G bumper cars. And if you are caught outside, your terrifying ascent happens incredibly fast. At minute 1, you're already 15 meters high. By minute 3, you're 150 meters up. By minute 5, you're dangling 500 meters above the shrinking rooftops. And honestly, the worst part? You're kicking your legs frantically, but the air is too thin to swim through. There is absolutely nothing to push against. Let's see how this builds. Section 3. Oceans boil. Air escapes. See, gravity wasn't just holding you down. It was holding all of our air down. Gravity acts like a transparent lid, packing gas molecules tightly to create our atmospheric pressure. Without gravity, that lid is just gone. The atmosphere expands rapidly outward into the vacuum of space at over 1,000 kilometers per hour. As the pressure plummets, we hit something called the Armstrong limit. This is the exact pressure threshold, 6.3 kilopascals, where water boils at room temperature. Every ocean, lake, and river erupts instantly. Massive plumes of white vapor shoot into the sky, and because of surface tension, the top layers of the ocean detach into these giant, translucent, floating spheres of seawater, literally completely filled with confused whales and sharks swimming inside them. Section 4. Expanding Earth and Strange Fires. All right, so from minutes 15 to 30, the disaster moves right beneath our feet. Our planet is essentially a highly compressed sphere of rock and liquid iron. The core is squeezed inward by gravity to the tune of 3.6 million atmospheres of pressure. When gravity drops to zero, It's exactly like letting go of a tightly squeezed rubber ball. The Earth physically stretches. The crust expands outward by several meters, triggering mega earthquakes that literally snap tectonic plates in half. And with no weight holding down the pressurized magma in the mantle, anti-gravity volcanoes erupt simultaneously all over the globe, shooting columns of lava straight up into the air like fountains. Now, as expanding crusts shatter gas pipelines, fires are going to break out everywhere. But fire behaves totally differently without gravity. On Earth, gravity pulls heavy cold air down, pushing hot air up, which gives fire its classic teardrop shape. But in zero gravity, there is no up or down, meaning there is zero convection. The flames turn into eerie, perfectly round, translucent blue spheres. These glowing slow-motion domes of doom silently consume the oxygen right around them, turning into floating clouds of toxic carbon monoxide. Section 5. A drift in deep space. The cosmic drift. Let's zoom out to the cosmic scale for minutes 30 to 45. What on Earth is happening to our entire planet? Earth normally hurtles around the sun at over 107,000 kilometers per hour, kept in a nice, stable circle by the sun's gravitational leash. With the switch flipped off, that leash breaks. Earth flies completely off the grid in a perfectly straight line, directly into the dark void. In just 1 hour, our planet drifts a staggering 108,000 kilometers off its normal orbital track. And we definitely aren't the only ones snapping off our leash. Earth's gravity was the only thing keeping the moon tied to us. It instantly shoots forward like a rock released from a sling, drifting over 3,600 kilometers away. Meanwhile, the 8,000 satellites in low Earth orbit, your GPS, your internet, they are no longer in free fall around Earth's curve. They just scatter out into deep space in random directions, literally like marbles dumped onto a glass floor. Back down on the surface, if you are lucky enough to be in a sealed underground bunker looking up, the daytime sky is completely unrecognizable. Because the air molecules that normally scatter sunlight have drifted off into space, the sky turns pitch black in broad daylight. You can see sharp, distinct stars right next to a blinding white sun. And hovering right at the equator is a 200-kilometer-high ring of floating debris, oceans, skyscrapers, topsoil, and cars just suspended in the dark void. Section 6. The devastating snapback. But humanity's 1-hour free trial of zero gravity is almost over. We hit minute 59. For 59 minutes and 50 seconds, Earth has been a physics-free playground of utter chaos. The atmosphere is stretched thin, cities are dismantled into floating puzzle pieces, and the crust is completely cracked. But what happens at exactly minute 60, when space-time violently warps back into a heavy bowl around the mass of the Earth? Prepare for the kinetic bombardment. Boom, gravity returns at 9.81 meters per second squared. Everything that spent an hour floating up to 200 kilometers high suddenly stops rising, and then it all falls. This is a terrifying terminal velocity acceleration. After just 10 seconds, trillions of tons of debris are falling at 350 kilometers per hour. Within 2 minutes, entire skyscrapers and oceans are hitting hypervelocity speeds, smashing back into the planet and exploding with the force of millions of megatons of TNT. At the exact same time, the escaping atmosphere gets violently sucked back down. Through a process called adiabatic compression, which is basically when a gas is compressed quickly, it rapidly increases in temperature. This sudden downward rush heats the compressed gas to thousands of degrees. The friction is so incredibly intense that it literally sets the sky on fire. Every floating piece of trash or furniture burns up in atmospheric reentry, raining white-hot ash and molten metal across the unrecognizable rubble of the surface. So, does anything survive this? Surprisingly, yes. Deep-sea ecosystems around hydrothermal vents hardly notice the event at all, thanks to the immense water pressure buffering the blow. Extremely tough microscopic life, like tardigrades and deeply buried seeds, ride out the destruction in the billions. And a tiny fraction of humans, specifically those sealed tight in deep military bunkers or nuclear submarines, will eventually step out to restart human civilization from absolute scratch in a world with zero infrastructure. We complain about gravity all the time, right? When we drop our phones or trip on the stairs. But as this quote beautifully captures, gravity is the invisible hug that keeps our air in our lungs, our oceans in their beds, and our planet wrapped safely in the warmth of the sun. Without it, the universe is just a chaotic cloud of floating dust scattering into absolute nothingness. It really is the ultimate architect of stability. So the next time you spill your coffee, maybe give a little thanks to the curvature of space-time. It definitely leaves us with a truly fascinating thought experiment to ponder. If the countdown started right now, Where would you hide if gravity turned off for an hour?
Please like and subscribe.